Hello guys, so the dataset which I've been working on for my home assignment is the sales advertisement simple linear regression. So this dataset features different ways that various companies go for promoting their sales, and the three namely are TV, radio and newspaper. So this dataset is basically a dataset of various companies trying to advertise their products using these three ways and how it affects their overall sales. So yeah, this is my code that I've uploaded on Google Colab. So I'll add my dataset here. Yeah, okay, so of course first we have the libraries to import. Yeah, done pretty well. Okay, so now I have defined a clean string function for cleaning my strings, cleaning my dataset if there are any redundancies or any special characters in my dataset like slash, colons, or numeric values. So I'll pass them to this function. So yeah, yes for that. Now I'll read my dataset advertising.csv. Okay, printing the first 50 values. Yes. So uh, there are five columns in this dataset, namely the index, then the sales to TV, sales to radio, sales to newspaper, and the overall sales made. Now, yeah, now this is the dataset from bottom 50 values. Now, before going into the regression part, it's important that we do get some pre-information about the dataset for getting some prerequisite information, like getting some information about our dataset, number of rows, number of columns, dataset name, like so. Here's that. Now my dataset has 200 rows and 5 columns, the 4 columns and then the index values. Now before working on my datasets, it's important that I remove any null values which are likely to be represented as NaN. So I'll check for any null values. So yeah, since this dataset is so great, I don't have any null values here. And if there are any null values, then we do have certain methods to fill them up. For instance, we can use the bfill method, that is the backfilling method, but since we don't have any null values here in this dataset, we won't be needing it much. Yeah, now okay, so the dataset which I have put on is a simple dataset, like it is not a dataset with lots of ups and downs and lots of redundancies, or a dataset in which I would need mean, count, minimum or standard values. But generally before going into the regression part, we take a bit of a fair idea about the dataset. So we do it by the describe function. Now yeah, this again the same thing which I did earlier, getting the rows and columns, the dataset length. Now I'll plot the sales distribution plot here. So yeah, did I do the feature selection part? Yes. Now as I told you guys, I have 5 columns here, the first column being of index which I don't need at all. So I'll select my features, important features that are important to me, like TV sales and radio and the overall sales. So I'll remove the column index. Now it's important that if I'm working on a data set which has lots of ups and downs, so if I need to get a fair idea of the majority values which fall onto my targeted area, so I remove the outliers. But on this data set, I see I don't have much of outliers. Most of the variables falls on the sales range. So yeah, that's that. Outlier analysis. Yeah. You can change the parameters according to yourself, depending on what exactly is your range of outliers. Okay. So Yeah, now the missing values, since we don't have any missing values, these are the values which are neither null or none, but they are just missing, like they are blank values. So I have applied the mean filling here. So yeah, if any values there are empty, I can directly fill them with the mean. Then the sales distribution plot, how the sales has been affected due to all of this various methods. Now, one thing which we can always do before going for a regression part is to get a brief idea, uh, to know about if there is some direct relation of one parameter with the overall result. So I have plotted a sales distribution graph over time. Um, we can define it as a pair plot or a scatter matrix. So yeah, this is my pair plot, the complete pair plot or a scatter matrix if you would like. Yeah, of course, this is TV with sales. This is TV with TV. These four are, they are just they are reflections of themselves. So these are not to be taken into consideration. But seeing the growth of TV with sales and seeing the growth of sales with TV, we see that TV and sales, like we can just share somewhat of a linear relationship. As sales increases, the ratio of, as TV increases, the ratio of sales also increases in a linear format. So yeah, maybe TV does, like advertisement to the TV does impact the sales in the most visible way. We also get a similar result when we plot the scatter matrix. Okay, so library issues, yeah. Okay, but we do get the brief idea in the pair plot itself. So yeah, that's that. Heat map, it's not basically very important to draw a heat map, but if we do need to get a fair idea of the shift of volume, where the volume is maximum, so we can plot a heat matrix, like plot a heat map. Okay, so heat map tells us about the volume of relations between various attributes. So yeah, that's what I said. The color value of the cell is proportional to the number of measurements. So it's not important, but if you need to know the volume of relations between various attributes, like the volume of relation between TV and sales, or TV or radio and like, so you can go for the heat map. Now, yeah, we need to normalize our data and also define our x and y axes. Now these are label encoders and one hot encoding. If suppose your data has some categorical values, some string values which you cannot process directly for linear or any sort of regression, it's suggested that you go for one hot encoding. So yeah, there are both kind of encoders which I have defined here, label encoder and one hot encoder. But we won't need them here since we are being on a very clean and numeric data set. Okay, so now I'll define my x and y axes. Obviously, I will drop my sales column from the x-axis because it's my result and I would need it only in the y-axis. So let me define that. The libraries. Okay, so now before going into the training part, it's evident that we need to split our data set into training and testing set. The ratio of testing to training I have used is 0.2 since the data set is small, but ideally you can shift it anywhere between 0.7 to zero point 0.8. So yeah, now we will go with the linear regression first. Okay, so my mean squared error is 10.9, r square is 0.43, and mean absolute error is 2.619. Okay, my polynomial regression 0.571. This is my decision tree. Now linear regression is obviously the simplest way to go for it. Polynomial regression, yes, we would have our increased number of variables. Decision tree, Yeah, sometimes expected to give the best value, but here it's giving a negative value, so it's not feasible for my model for this particular data set. We'll go for random forest. R square is zero point 0.2. Okay. Neural networks. Now, yeah, for neural networks, we all know that we need to add some layers. We need to use keras and stuff, and the different regressors which I have used here in my neural networks are SGD regressor, the lasso regressor, the ridge regressor, and yeah, that's all. So my SGD regressor gives me 0.46. My lasso gives me around 0.48, and ridge 0.44. So we know that the greater the value of R, the better my model fits. Better my model, the better the fitting of my model according to this data set. Since the size of my data set is small, I would obviously like to go for an R score, which is my highest, and the R score the highest R score I'm giving here, R square score I'm getting is 0.571. So yes, polynomial regression is the best for this particular sales data set. So yeah, that's all. After running all the techniques for this particular data set, we find that polynomial regression fits the best. Thank you.